In this video on mechanisms in AS organic chemistry, we're going to look at eliminations of water molecule from alcohols and also of HX from halogenoalkanes. Okay, so the first one we're going to look at is the mechanism for the loss of water from an alcohol. Now, this mechanism is caused by the action of a catalyst. It's a hydrogen ion catalyst, so it's an acid, and that acid we use is concentrated sulfuric acid. You may recall doing the reaction using concentrated phosphoric acid. Okay, so the first step is shown here. We have got propan-2-ol. We've got a lone pair on our oxygen for our alcohol, and that attacks a hydrogen ion. This gives us this intermediate here. Now, we've got a positive charge on an oxygen. This is an energetically unfavorable situation. So we lose a molecule of water from this intermediate. And we do that by returning a pair of electrons back to oxygen with this curly arrow by breaking the carbon-oxygen bond. This leaves us with a carbocation intermediate. Okay, so it's a cation because it's a positive ion, and it's based on a carbon. And now this carbocation is transformed into an alkene. Now the way that happens is that a hydrogen on a neighbouring carbon loses a hydrogen ion. Now we don't have a base in here to try and take that hydrogen. It just the bond breaks naturally. Now we could have a hydrogen being lost off this carbon or this carbon here. I've shown it coming off this first carbon. Now it is just purely by chance which way it happens. Now because we're dealing with propan-2-ol as our starting material, it doesn't matter which one falls off. We get propene being formed at this, regardless. So just be careful of this, because more complicated alcohols can lead to both positional isomers, so having like 1 enes versus 2 enes if this was a longer carbon chain, and also if you got different groups attached to your carbons, you could end up with EZ isomers. Okay, so after you get propene being formed, you get a molecule of water, which we lost here in this step, and our hydrogen ion is regenerated, again showing that this is a catalyst. Okay, so that is the mechanism for the dehydration of water from an alcohol, or as the name of the mechanism is, elimination of water from an alcohol. Okay, next we're going to look at the reactions of halogenoalkanes in their elimination reactions. So this time we are reacting with a base. Okay, now a base is defined as a proton acceptor, and the most common base we encounter are hydroxides. Now, elimination reaction is where there is a removal of a molecule from a saturated molecule to form a non-saturated molecule, and this reaction here occurs in the presence of hot anhydrous conditions, i.e., we use an alcoholic solution solvent. Okay, we don't use water. If we use water as our solvent, we get an alcohol being produced in a nucleophilic substitution reaction. In this reaction, we just get the alkene being produced. Okay, so we've got bromoethane reacting with potassium hydroxide, forms ethene, potassium bromide, and water. Okay, so the reaction mechanism, 3 marks for this mechanism. The first mark is for showing a curly arrow from the lone pair of electrons on an oxygen of a hydroxide ion. That attacks a hydrogen on a carbon which is next door to the carbon holding the halogen. As that bond is formed between the oxygen and the hydrogen, the carbon-hydrogen bond breaks and that electron pair gets turned into a carbon-carbon double bond. As that occurs, the carbon-bromine bond breaks and we form a bromide ion. Okay. So it's quite a complicated process to have these 3 pairs of electrons moving in exactly the right place at the right time. But that is just the mechanism. Okay. So thank you for watching.